So let's have a look on the INCAR file. Well, INCAR file tells to VASP what should we do or what VASP should do with those four files, what to do and how to do. And so NCAT is well, so-called energy of cat, and it has some physical meaning, but the describing of the meaning will take some amount of time, and I'll just do it later. And usually 500 is pretty enough. Here, ECIF is responsible for the way how VASP is going to relax your unit cell. How does VASP is going to um, optimize positions of atoms or volume or angles between uh, directions of unit cell. And so there are three numbers that are important for us. They are 7, 3, and 2. Well, number 7 in if is equal to 7, that tells to VASP that it should relax the unit cell. It should optimize the volume of the unit cell without changing the positions of atoms in the unit cell. It can actually, so for example, if we have unit cell with translation constants that equal to 4 angstrom, well, in A or in X, Y, and Z, so it can, after optimization, we can have 0.1, 4.01 angstroms in Z direction, 3.9 in Y direction, and X can be the same. So actually it can change in the really different ways, and that should be okay. The only thing with 7 is that it doesn't change the ratio inside of the volume inside of the unit cell. And so let's say that atom one of silicon atom is located in the middle of the unit cell, and after optimization the silicon atom will still remain at that condition, at that position. And the next number is number 3, which gives to us absolute freedom. And yeah, it can change whatever VASP wants. It can change the angles between uh, X, Y, Z bases of the unit cell. It can change positions of atoms. It can change the volume and whatever VASP wants. And number 2 is to optimize unit cell, but without changing the volume. So it just relaxes the positions of atoms and optimizes the positions of atoms, so it will uh, the volume, the angles between directions of unit cell, bases of unit cell will remain the same, and only the positions inside will change. So if in if you have number 7 and silicon is in the middle of the uh, unit cell, it can change its position in case of 2, and it won't stay in the middle of the unit cell if it is you know, better in terms of potential energy of unit cell. Well, we'll talk about it later. And Ibrion Tech is usually number 2. Um, yeah, 2 is, it tells that VASP 2 is used for difficult tasks, and well, you just always use that. And sometimes when your unit cell is far from ideal, you can use number 3. Uh, and yes, that's all you should know about the IBRION tag. A smear tells to VASP which type of material we are going to optimize, and well, if it is silicon, it is a semiconductor, and for semiconductor, you should use -5, which is so-called tetrahedron method. But that method can lead to mistakes when we want to calculate band structures. And well, actually, it's better to use 0. And yeah, so for metals, we always use number 1. This is just the rule of VASP, and uh, yeah, that's all. Sigma is quite not important right now. And NSW says how many ionic iterations VASP can perform until it ends. So we have sigma, which tells that the difference of energy between previous and the current step should be less than 0.01 electron volts. I think so, yeah. And if we reach that accuracy, well, VASP stops automatically, and there is no need to perform all of 1000 ionic iterations. So maybe 50 or 16 will be enough, and yeah, it just ends where accuracy is reached, and it's better just to use a big number here, maybe 10,000. I don't know. Anyways, it won't reach 1000, and it's rarely reaches 100, and yeah, it will stop much earlier. Well, next is I charge row, I charge tag, and it contains information about charge distribution in unit cell, and the well, that tag number 0 tells that we don't have CHG car right now, and it should start all of the calculations without any information about the initial positions of initial charge distribution. But when we want to calculate band structure, we should have that CHG car, and when we run band structure calculations, we will set whether 1 or 11 or maybe another number. And also, do you see that IBRION here? So when we run band structure calculations, let me here. When we run band structure calculations, we need we don't want to change the positions of atoms. We already have optimized unit cell, and we already have charge distribution for that unit cell. And to tell that to VASP, we will set I charge equal to 0 or 11. That says that we already have charge distribution. And we will set NSW equal to 0, so there will not be any ionic iteration. And also IBRION should be equal to -1, and that says that we don't want to change the positions of atom. Okay, and uh, all of other rows are not important right now. I'll describe them a bit later. And yeah, that is all we need in INCAR file right now. Uh, well, next time I will tell you about kpoint file and podcar file, and that will be the end of the introduction into VASP.